No, today is not a holiday. And next Monday, right at the same time, we have our first exam. Today, we are going to go over the sample exam. I hope you have a copy or at least take good notes. It finally is recording, so we should be okay, even if you don't have a copy. Are there any questions before we get started? Let me just say one more time before we go. The exam itself is designed to look exactly like the sample exam. That's an anxiety reliever for you. As you look at it, you say, oh yeah, I've done this. Everything is different, however. It's not a trivial exam. Please make sure you have all your tutorials done. Lots of the questions on the exam come straight from tutorials. All right. First question, we have a sample of 5.5 grams. Which of the following expresses that in milligrams? We remember that milli is the prefix for 10 to the minus 3. Our given in this problem is going to be our 5.5 grams. We want to find milligrams. The ratio for grams to milligrams, there are 1,000 milligrams in a gram. 1,000 times 10 to the minus 3 is 1. So we start off with our given. Going to multiply it by a ratio. Grams will cancel. 5 times 10 to the third. And there it is. Now this problem comes straight out of the tutorial. Metric conversions, grams to milligrams or whatever. And as I write the exam questions, what I do is I would go to this tutorial, hit new problem, and write it down. So it's a great way to practice to do these sorts of things. Here we have a table. We have symbol of elements, proton, mass number, charge, electrons, and neutrons. Let's start with the first. Question 2 is magnesium. I will give you a periodic table that looks pretty much like this one. First thing we do is we find magnesium, and we find its atomic number is 12. We remember that the atomic number is the number of protons in the nucleus. So this gives us 12 protons. Now in the table we were given that we had 10 electrons. This is 12 positives, 10 negatives. 2 more positives than negatives, so the charge plus 2. Finally, the mass number is 24. We remember that the mass number is the sum of protons plus neutrons. If we have 24 as our mass number and 12 are protons, 12 are neutrons. The next one is lead. Lead is down here, atomic number of 82. That means it has 82 protons. Now, mass number. In the table we were given, we have 125 neutrons. We also have 82 protons. The mass number is simply that sum. 125 plus 82, 207. Finally, the number of electrons. We are told that the charge is plus 3. We have 3 more positives than negatives. The protons are the positives, so we must have 3 less electrons. 82 minus 3, 79. Yeah.
Is the periodic table that's on the blackboard, is that the one you're giving us?
That's what you're going to get. Learn to love it. Yeah.
How big is the milk card again?
Try that again.
How big is the milk card that you're on this degree?
Oh, 3 by 5. 3 inches by 5 inches, not 3 feet by 5. Yeah, you can bring that just in case, you know, it teaches you to write things very, very small. And after, you know, this is personal experience, so, but after you take the time to write all these little tiny things on the card, you remember them so well you don't ever have to look at the card. Of course, this comes from protons, electrons, and neutrons. Again, if you need practice, simply go to the tutorial and try it. Question 4. We are writing the formula for ammonium hydrogen carbonate. Now remember, we don't have lab on Wednesday. Instead, you have the nomenclature review sheet online. That's lab 5. Print it, do it. You can check it because there's an answer sheet. Print it, do it, hand it in the day of the exam. As soon as we sit down, just like this. That's the only way you get credit for lab 5. All right. Ammonium hydrogen carbonate. If you don't remember, and maybe you have it written on your little card, ammonium is NH4 for the +1 charge. Polyatomic ion looks like that. Carbonate is the parent of the carbon family. It's CO3. Now carbonate is a -2 ion. Ammonium is a +1. But this is hydrogen carbonate. So carbonate looks like this. To make hydrogen carbonate, what we do is simply put a hydrogen on one of the negative oxygens. To show that, we simply put the hydrogen in between here. That is ammonium hydrogen carbonate. The ammonium is a +1, carbonate is a -2, and the hydrogen that we bring in is a +1.
Do you want us to write that on the exam?
Nope, just the formula. Any questions, guys? Names the formula. Cesium phosphate if you want more practice. All right, we're doing an atomic symbol here. We have an element that is anionic with a charge of -2. We are told that it has 18 electrons and 16 neutrons. First thing you have to figure out here is what is the element. We look at our periodic table. It is anionic with a charge of -2, right? That means it has 2 more electrons than it does protons. So how many protons? 18 minus 2. This is sulfur. Atomic number 16. Now we remember that when we write an atomic symbol, we start off with a symbol for the element. As a subscript in front of the element, we put the number of protons. That's the atomic number. And as a superscript up here, we put the mass number. The mass number is protons plus neutrons. 16 plus 16, 32. Now this guy is charged. So, following this as a superscript, you put the charge. And that's it.
And you want all of the numbers on the outside for the
Yep.
example. Okay. So your number of neutrons is just the atomic number.
Right. Any more questions? All right, there's a simple density table. There's a density table on the exam. Here we're looking for mass. We know volume and we know density. If you don't remember it, write it on your card. Density is mass divided by volume. Now here we are trying to figure out what mass is. So mass is going to be density multiplied by volume. Here is our density, here is our volume. We simply multiply those two together. The mass of this substance is 9.84 grams. On the exam, what I did is I simply went to this tutorial and hit new problem a couple times, came up with a random set, and that's the problem. Good way to practice. Any questions? All right, which of these is wrong? These are all polyatomics or their elements. And you're supposed to know the name, check the charge, whatever. Phosphate. Again, on your card, you can put a little list of polyatomics if you want, the important ones. Phosphate, we know, is PO4, and it's a -3 ion. The other very common one is phosphite, PO3, but it's also -3. So this one's good. Let's skip B. That's a giveaway. Aluminum. We find aluminum on our periodic table. It's right here in group 3. That means it'll be a +3 cation. Aluminum, +3, aluminum cation. Yep, that's good. Oxide. Again, we look at oxygen on our periodic table. Right there in group 6. It'll pick up 2 electrons. It's a -2. That's good. Nitrate, the parent of the nitrogen family. We remember that they're all -1, so that's right. NO3 is nitrite. The other common one is nitrite, NO2. Still -1. That leaves us here with B. B is obviously wrong. Sulfate is SO4. If we added 1 oxygen, we would have persulfate. But it would still be -2. Any questions? Significant figures. Everybody loves significant figures now. There's a number. First thing we do is we say, does this number have a decimal point? Well, yeah, it does, right there. That means that the leading zeros are not real, but trailing zeros are. So we simply get rid of the leading zeros, and then we count. 1, 2, 3, 4. That's it. Any questions? The problem on the exam comes straight from significant figure tutorial. All right, percent composition. We have a compound, C4H8. What's the mass percent of hydrogen? Now we remember how we do this. We start off with a mole ratio. There are 8 moles of hydrogen for every mole of C4H8. Every hydrogen weighs 1.008. So our equation for this is going to be simply 8 times 1.008 divided by 56. 8 moles of hydrogen for every mole of this stuff. 8 times 1.008 divided by 56. Multiply this by 100 to get percent. There it is. 14% hydrogen by mass. If you want to practice percent composition by mass tutorial, this is where the problem on the exam came from. Any questions? Yeah.
So for the on the exam, there's 2 choices. So there's 14.37, 1, 7, and 14. They won't be same choices.
Oh no, they're different?
Yeah.
Okay, well that's the right answer. I'm sorry if that's slightly different. I messed up. Again, I was just trying to make sure you're paying attention. All right, we express things in scientific notation all the time. We remember in scientific notation, we only include significant figures in the coefficient. The exponent is the number of places we have to move our decimal. So this guy, 0.00000013. We want to put our decimal between the 1 and the 3. That's 7 places to the right. So that's a 10 to the -7. we only have two significant figures here, 1.3, because these are all leaving, they go away. So we have 1.3 times 10 to the minus 7. If you need help with scientific notation, here's a tutorial. Same sort of number, enter the numbers. Remember, all the significant figures go in the coefficient. All right, everyone loves electron configuration also, because even though it sounds so very advanced, it really is simple. We just put this in the context of the periodic table. We're looking for carbon. Carbon is here in the second period. That means, because it's in the second period, that the first period is totally full. The first period can hold 2 electrons, and we show that as 1s2. Now we look at our answers, and will they all have a 1s2? Shoot. Okay. Down to our second period. These two represent the s orbitals, and they are full. So this is 2s2. Over here, we can eliminate this guy, that's stupid, and we're left with these 4. Now we fill in p electrons. This is a p block, and we have 1, 2 electrons in the p block. So we're down to these 2. C has electrons in the third period. Second period element, that doesn't work, does it? If those go away, correct answer is simply 1s2, 2s2, 2p2. If you want any practice, it comes straight from this tutorial. Now on the exam, for this next problem, you actually have to do a calculation and write a number. We have a sample of gas with 1.88 times 10 to the minus moles of the gas. How many particles is this? What you need to remember is that if we had 1 mole of this gas, any gas, it would have 6 times 10 to the 23rd particles. But we don't have 1 mole. We have 10 to the minus 9 moles. So that's going to be our given. We'll start off with our given. Our ratio is simply going to be 6 times 10 to the 23 particles per mole. We've set it up correctly. We know that because moles cancel. On your magic calculator, and make sure you bring it. I actually will have school calculators available if you forget, but I don't know how to use those either. So bring your own, one that you're happy with. 1.88 times 10 to the minus 9 times 6 times 10 to the 23rd. 1.13 times 10 to the 15. Any questions, guys? All right, physical changes. They're always accompanied by a change in state. In general, anytime you see the word always, it's always wrong. Change of state can happen, but it's not required. Physical changes result in the formation of homogeneous mixtures, not new compounds. Well, they never make new compounds, number one. And number two, homogeneous mixtures are solutions. Totally different. Number three, they always produce new elements. Well, that would be nice, lead into gold. That doesn't work either, unless you're doing radioactive decay. But that's chapter 11. We're not there yet. So that's not right either. Finally, none of these responses are correct. With a physical change, you start with one substance and you wind up with the same substance. It's just different somehow, but it's the same stuff. Chemical change, you start with one, you wind up with something new. All right. Which expressions are true? Molar mass divided by mass is moles. Well, that sounds familiar, but it's not quite right, is it? It's mass divided by molar mass that gives us moles. So that's not good. If we take molar mass, that's grams per mole multiplied by grams, do we get moles? No. Again, molar mass multiplied by moles gives mass, but not the other way around. Mass divided by the number of moles is molar mass. Well, actually, that sounds right, doesn't it? The number of grams per mole is the molar mass. So yeah, that's right. All right, on Wednesday, remember, you are doing nomenclature review sheet. So, you will for sure know the name of P2O5. The first thing you do is you look and you see what you're dealing with here. Phosphorus is a nonmetal, so is oxygen. This is a molecular compound. Remember, the two really differ in terms of nomenclature because with a molecular compound, you're going to use multipliers. Now in this compound, we have two. Phosphorus, that's a di. And we have 5 oxygens, that's a pent. So we simply look for diphosphorus pentoxide. And there it is. Remember, you only use charges for ionic compounds. And again, you must use multipliers on both elements. If you want practice, here's a tutorial, P2O5, diphosphorus pentoxide. right, for our next one, we have another table. We are doing moles. Okay. On the exam, I don't remember which one is missing, but somebody is. We note if we want to have moles and we know mass and molar mass, we remember mass times molar mass, mass divided by molar mass is moles. So we simply take our mass, divide by our molar mass. It's about what? 0.8, 0.9, yeah, 0.921. Here's the tutorial it comes from. And once again, to write the exam, I click new problem and write down the numbers. Great way to practice. Lewis structures. Yes, you will get to draw a Lewis structure. Here we're dealing with CO2. Now remember, there are two ways you can approach this. You can do it like it's done in the tutorial, following the rules. You can't go wrong if you follow the rules. Or you can do it like I do, just kind of put dots everywhere and line them up. That's what we'll do now. Carbon. Group 4, it has 4 electrons. Oxygen, group 6, it has 6 electrons. We have 2 oxygens and 1 carbon. Carbon's going to be in the middle because it's first. So, here's our carbon, and we put an oxygen on each side. Now our goal here is to give everybody 8 valence electrons. Right now carbon has 2, 4, 6, and each oxygen has 7. Not a great situation, but we can remedy that by pairing things up to make double bonds. If we take this and this, and simply move them in to make a double bond. Now this oxygen is 2, 4, 6, 8, and it's happy. Carbon still has 2, 4, 6, 7, not quite so happy, but we can move this guy and this guy in, make another set of double bonds. Now, everybody has 8. Carbon has 2, 4, 6, 8. So does each oxygen. 2, 4, 6, 8 for each oxygen. 2, 4, 6, 8 for the carbon. And that's our structure. Now remember, the tutorial does it slightly differently by the rules. You're certainly welcome to use that. You can't go wrong with it.
Can you go over again how we find the number of valence electrons?
What we did was we looked at the groups that they were in. Carbon is in group 4, therefore it has 4 valence electrons. Each oxygen was in group 6, so it has 6 valence electrons. Simply look at the main group numbers. Another nomenclature question. K2O. Again, we want to see exactly what we're dealing with. Potassium, that's K, right here in group 1. And by George, it's a metal. So we know this is an ionic compound right away. We do not use multipliers. What we do simply is just list the elements in the order that they appear. So this is potassium and oxide. Potassium is not a transition mineral. We don't need to show its charge. Potassium oxide works. If you want to practice, naming ionic is where you go. Which of the following compounds will the cation have a +3 charge? This is simply an exercise in finding them on the periodic table and identifying the group number. Calcium, group 2, +2 charge. Magnesium, also group 2, +2 charge. Ammonium is the cation here. We remember ammonium is our polyatomic, and it's a +1. Aluminum sulfide, aluminum, group 3. It will be a +3 charge. Now the last guy here, phosphorus trichloride. Phosphorus is a nonmetal, so is chlorine. This is molecular, so nobody has a charge. Any questions? And the last one, simple mole calculation. Now, I have to admit that I kind of messed up. I put the same problem twice on the sample exam, just different numbers, but we can do it twice. We have 42 grams of copper. The molar mass is 63. How many moles is that? We remember that mass divided by molar mass is moles. So we take our mass, take our molar mass, simply do the division. 0.67 moles. And when I wrote the sample exam, I meant to put in actually a density problem. And instead, I grabbed another mole problem. My mistake. How many moles is 84 grams of cadmium? Cadmium has a molar mass of 112. Same exercise. 83 divided by 112. Mass divided by molar mass. 83 divided by 112.75. Once again, this comes from the simple tutorial. Mole mass conversions, how many moles, so many grams of whatever. All right. Next Monday at this time, we will all be here. I will give you a periodic table. Make sure you bring your calculator. Tutorials and quiz 1 must be completed before the exam.
And those are all extra credits.
Quiz 1 is not. Tutorials are all extra credit.
Okay.
But if you want credit, you have to do them before we take the exam. Remember, no class on Wednesday. Instead, do the nomenclature sheet, hand it in Monday, a week from now, before we take the exam. Here's our list of tutorials. Once again, there are 14, something like that. There's a lot. A lot of potential points here. You must do them on Blackboard to get the points. Now, today's lecture has been very short. This is another mind game. We did this whole thing in 30 minutes or so. And that's with me talking way too much. On the exam, it will look just like this. You can whip through it and be done in 15 minutes. Just look at it that way. All right, good luck on everything. And if there are no questions, we're done. One second.